Hello, welcome back to Project Study Buddies. We are doing IGCSE Mathematics Chapter 5, Fractions. If you are still confused and have questions by the end of the video, do ask us by leaving comments down below and our team will answer them as soon as possible. Without further ado, let's get started. So these are the 5 subtopics for the chapter. A fraction is part of a whole number. Common fractions are written as numerator over the denominator. A, the numerator, and B, the denominator, can be any number, but B cannot be 0. If you multiply or divide both A and B by the same number, you will get an equivalent fraction, which has the same value as the original fraction. This should give a clearer representation of the same value. And don't worry if you don't understand this yet, we will talk about addition of fractions later in the video. Simplest form is simply a fraction that cannot be divided further, due to numerator and denominator not having a common factor other than 1. For example, 25 over 35 can be further divided into 5 over 7 since they have a common factor 5. Whereas 5 over 7 cannot be further divided since they don't have any common factor other than 1. Therefore, 25 over 35 is not in its simplest form, but 5 over 7 is. Cancelling is a shorter working to show division of both numerator and denominator, instead of writing 25 divided by 5 over 35 divided by 5. These are some questions that you can attempt. Please do post if you want to, because I'll be revealing the answers now. 3 over 15 have a common factor 3. They can both be divided by 3. 5 over 8 is already in its simplest form, so they cannot be further divided. And the second question. Okay, so here we are at 5.2, the second subtopic, operations on fractions. We are going to look at how to multiply, add, subtract, and divide the fractions, fraction with decimals, and further application of fractions. So, to multiply fractions, first you multiply the numerators, then multiply the denominators, then you express the fraction in its simplest form like what we did earlier in 5.1. Or you can simply simplify the fraction or cancel before multiplying. Then the answer you get would be in its simplest form already. But don't worry if you're not quite sure or familiar with what is it about. We are going to go deeper into it in the next slide. So now I'm just letting you know the general idea of this section. Question 1. There are 2 ways you can do this. Multiply the numerators, multiply the denominators, simplify them. Or the other way, like the working in blue, you can cancel before multiplying so you don't have to simplify the answer, since you get the simplest fraction already, 3 over 14. Question 2, you make the whole number over 1. Then you create a fraction so they can multiply each other, then you solve it like what you did in question 1. Question 3, you turn the mixed number into an improper fraction. So 4 times 2 plus 1 over 2 gives you 9 over 2. So 4 1 over 2 equals to 9 over 2. 4 1 over 2 is the mixed number and 9 over 2 is the improper fraction. They both have the same value or same decimal value, they're just in different form. But improper fraction is what we need when we want to multiply the fractions. There's 2 types of cancelling we have talked about in this chapter. Both cancelling allows you to obtain your answer in the simplest form. So first, you cancel a fraction to show that you divide both numerator and denominator by a common factor. Second, you cancel before multiplying. So there are 2 conditions for this. First, you can only cancel numerator of the first fraction with denominator of the second fraction, or vice versa. You can never cancel both numerators or denominators of first and second fraction. Second condition, the numerator and the denominator need to have a common factor. So as you can see, the two examples given here, 5/2 times 5/3 and 1/3 times 7/3. We can only solve them in the traditional way, which is multiply the numerators, multiply the denominators, then solve into its simplest form. We can't cancel it before multiplication. Second type of question, multiply a fraction with a whole number. So if you encounter a question asking you to multiply a number and a fraction, just make the whole number over 1. And there you go, a fraction is formed. Now you can multiply the two fractions. Another way to look at it is that you make the second fraction the same denominator. It might be better for you to visualize or understand if you make them have the same denominator, but it's not necessary. You only have to make sure the fractions have the same denominator in addition and subtraction of fractions. The third type of question, multiply a fraction with a mixed number. You have to turn the mixed number into an improper fraction. So what improper fraction means is the numerator of an improper fraction will be larger than its denominator. So here are some examples. You can pause the video if you want to, because I will proceed with the next part. So to turn improper fraction into a mixed number, you have to ask yourself two questions. First, maximum how many denominator can the numerator make? And second, how many is left? So here's an example using 7/2. 7 can make 3 2's. So 7 minus 3 times 2, or 7 minus 6 gives you 1. So 1's left. So the answer you get would be, if you turn 7/2 into a mixed number, 3. Since 3 2's can be obtained from 7, 1's left, over 2, keeping the denominator. I hope this allows you to better understand what this mixed number, improper fraction, and common fraction means. 1/4, meaning you have 1 whole pi, and 1/4 or 1/4 of the whole pi. Moving on to adding or subtracting fractions, there's one condition you have to make sure before adding or subtracting fractions. That is, the fractions must have common denominator. In this section, we are going to use knowledge of lowest common multiple. If you're not familiar with LCM, do go to chapter 1, link in description. For example, 1/2 plus 1/4. So to move on with adding or subtracting, you have to make sure they have the common denominator. So first, find the common denominator. You find it by finding the LCM of the denominators, which is 4. So the common denominator would be 4. Second, you find the equivalent fractions. So 1/2 and 2/4 are equivalent fractions. You multiply the numerator and denominator of 1/2, then you get 2/4. Then lastly, you add the numerators, 2 plus 1/4, giving you 3/4. So in short, 1/2 times 2 times 2 plus 1/4 gives you 2/4 plus 1/4 and gives you the answer 3/4. And question 2 is the same concept, but you have to change the improper fraction that you got for the answer to a mixed number. So 19/12 is 17/12. Question 3, the same concept, but remember to change the mixed number into improper fraction so you can move on with subtracting the fractions. So if value of the b, the numerator of the second fraction, is higher than a, the numerator of the first fraction, the answer you get will be a negative fraction. So just subtract as usual, like you would do with normal numbers. Do not swap b/2 with a/2, like b/2 minus a/2, because you'll get a different answer. The working might be quite tedious if you want to do LCM, so there's another faster way, which is to multiply the numerator and denominator of the first fraction by the denominator of the second fraction, and vice versa, multiply the second fraction's numerator and denominator by the denominator of the first fraction. But there's an extra step that you have to take, is that you have to simplify the answer, since if you do it that way, the denominator would usually be quite a big number. So the example of that is that Lcm method. So you know that the common denominator is 4 because the LCM of 2 and 4 is 4. So you multiply 1 over 2 by 2. 2 over 4 plus 1 over 4 gives you 3 over 4. And the other method is that you multiply each of the fraction by the denominator of the other. So 1 over 2 times 4 plus 1 over 4 times 2, and both gives you the same denominator, 8. And with this, the condition is satisfied. You can move on with addition or subtraction. So 4 over 8 plus 2 over 8 gives you 3 over 4. Moving on to the next section of 5.2, dividing fractions. So before this, we need to know what's reciprocal. So reciprocal of any fraction can be obtained by swapping the numerator and the denominator. So to find reciprocal of 3 over 4, you swap the numerator and the denominator, and you will obtain 4 over 3 as the reciprocal. Same goes for the others. To divide a fraction by another fraction, you multiply the first fraction by the reciprocal of the second fraction. So in short, a over b divided by c over d equals to a over b times d over c, since c over d's reciprocal is d over c. This is the detailed explanation. You can pause to read it through. And here's some exercises. So 3 over 4 divided by 1 over 2, you swap it to get the reciprocal. So 3 over 4 times 2 over 1, giving you 3 over 2, and make it to a mixed number, 1 over 2. Same goes to question 2, 5 over 8 divided by 2, meaning 5 over 8 divided by 2 over 1. So you swap it, 5 over 8 times 1 over 2 gives you 5 over 16. The next section of 5.2, fractions with decimals. Numerators and denominators will not always be a whole number. So in order to express these fractions in their simplest form, first, convert both numerator and denominator to an integer by finding an equivalent fraction. Second, check if the equivalent fraction is in its simplest form. That's what you need to do every time you encounter a fraction in the question. Question 1. 0.1 over 3, simplifying it. So in order to convert 0.1 into an integer to make an equivalent fraction, you multiply 0.1 by 10. There you get 1, which is a whole number. And 1 over 30 is already in the simplest form, so question is solved. And question 2, multiply both the numerator and denominator by 10. There you get 2 whole number, and they are already in the simplest form. And question 3, same thing. You can do either working. Further calculation with fractions. A school has 600 students. 2 over 5 of them are girls. How many girls are there in the school? So 2 over 5 of 600 is 240. So there's 240 girls in the school. 2 over 5 of workers of a company are males, and there are 360 males in the company. So how many workers are there in the company? 2 over 5 are males, and there are 360 males. So 2 over 5 of total worker is 360. So 1 over 5 must be half of 360, which is 1 over 180. So 1 over 5 of the total workers is 180. So 5 over 5 of total, which is the actual total, 1 of total, is 180 times 5, which gives you 900, the total number of workers in the company. There's also a shorter working. 5 over 2 times 360 gives you 900. You just multiply it by the reciprocal. Next subtopic, percentages. There's 5 sections of this subtopic. Equivalent forms, finding one number as a percentage of another number, percentage increase and decrease, increasing and decreasing by a given percentage. Lastly, reverse percentage. A percentage with the given symbol is a fraction with a denominator of 100. For example, 40% of 25. 40% is actually 40 over 100. So 40 over 100 of 25. Just multiply it, 40 over 100 times 25. And doing the cancelling and everything, you get 10. But be careful when you are using your calculator. Do not type 100 with a percentage symbol because you will end up dividing the answer by 100 again. Equivalent forms. We are going to convert percentage to decimal and percentage to fractions. So percentage to decimal, you divide by 100, and from decimal to percentage times 100, because percentage is fraction over 100 with denominator of 100. So 45% is actually 45 over 100, which is 0.45. 3.1 is 3.1 over 100, giving you the decimal 0.031. And notice that the decimal point moves 2 places to the left when it's divided by 100. And when you convert decimal to percentage, you multiply by 100, and the decimal point moves 2 places to the right. So moving to the right is times, and moving to the left is divide. Percentage to fraction. So 25%, 30%, 3.5%. 25% is 25 over 100, and you just simplify them to a common fraction, 1 over 4. Then 30 over 100, 3 over 10. 3.5 over 100 is actually 7 over 200 when you cancel them. When you divide 35 over 1000 by 5 by 5. So first, you write as a fraction with a denominator of 100. Then you simplify them. There you go, a common fraction. Second, when you want to convert from fraction to percentage, there's 3 examples here. 1 over 20, 1 over 8, and 3 over 40. There's 2 ways you can do it. First, you find the equivalent fraction with a denominator of 100. So like 1 over 20, you times 5 times 5, you get 5 over 100, and there you get 5%. And then for 1 over 8, you times it by 12.5, since 12.5 times 8 gives you 100, and there you get 12.5 over 100, giving you 12.5%. But there's also another way. I think it's quicker. You just multiply by 100, multiply the entire fraction by 100, and then simplify them. Cancelling in terms of simplify, So, like for example, 1 over 20, you just times 100, then you get 100 over 20. 100 divided by 20 is actually 5, so that's 5%. You get the same number. And for 3 over 40, you times it by 100, so you get 30 over 4, which is 15 over 2, and that's 7.5%. You can do the same to 1 over 8 too, and you will get 12.5% as well. Finding one number as a percentage of another number. First, write first number as a fraction of second number. Second, you multiply it by 100. So for example, express 16 as a percentage of 48. 16 over 48, writing the first number as a fraction of the second number, then multiply by 100, and you get 1 over 3 times 100, then 33.3%. Question 2, 18 as percentage of 23. 18 over 23 times 100, giving you 78.26, rounded up to 2 decimal place. Percentage increase and decrease. Sorry, there's a writing mistake here. So always remember the formula: final minus initial over initial times 100. No matter what you do in future chapters as well, it's always final minus initial over initial times 100. So cost of a book increases from $12 to $15. Actual increase of the value is actually $3. So as a fraction of the original value, they change the difference, final minus initial, over the initial is 3 over 12. So simplify it into 104 times 100 gives you 25%. Therefore, percentage increase of the cost is 25%. Or to put it in another way is that the value of book has increased by 25%. And for a price drop from $15 to $12 is the percentage change is still the same, but to be precise is minus 25%, since the percentage decrease of the cost is 25%. So value of book has decreased by 25%, the percentage change is minus 25%. Increasing and decreasing by a given percentage. Question 1. Increase 56 by 10%. So 10% of 56 is 10 over 100 times 56, giving you 5.6. So you add the 10%, 5.6, and the original 56, which is 100%, gives you 61.6. If you don't need to know the actual value increased, which is 5.6 in this case, then you can just consider the original value, 56 in this case, to be 100%. So you add 10% to the 100%, giving you 110% of the original value, 56. So just simply multiply 56 by 100 over 110 over 100, and that will give you 61.6. Decreasing 260 by 20%. So 100% minus 20%, you are left with 80%. So just find 80 over 100 times 260 gives you 208. Or you can just straight up go to 100% minus 20% equals to 80%. 100% is 260 minus 20%, which is 20 over 100 times 260. And that will give you 80%, which is 208. Sometimes we wonder, oh yeah, why not take 260 as 100%, 120%? No, because taking 260 as 100% and as 120% are actually different, and they will give you different answers. The last section of subtopic 5.3 percentage is reverse percentage. So given that value of an item after a percentage increase or decrease has been applied to it, what is the original value? Say that a jacket is sold for $108 after a 10% discount. So what's the original price? The new cost is 108, and this new cost is 90% of X, the original value, since 100% minus 10% is 90%. So in order to find the original, you have to go from 108. So 108 is 90 over 100 times X, because 108 is 90%. So you move it to the other side, divide by 90 over 100. Using what you have learned earlier, 108 times the reciprocal of 90 over 100, which is 100 over 90. And that gives you 120, your original value. And this concept is you are trying to undo the 10% decrease to find the 100%. And it's different from increasing the reduced value by 10%. As in, you take the 108 as 100% and you increase it by 10%. So the calculation is that 110 over 100 times 108 gives you 118.80. And this is an incorrect answer. The original value has to be 100% and not 110%. And 108 can never be the 100%. It has to be the percentage after the discount. The fourth subtopic, standard form. You use standard form to express very small or large numbers efficiently. Numbers are written as a number multiplied by 10 raised to a given power. So if a number is more than 1, the given power would be positive, and if the number is less than 1.0, it's a negative index. Standard form for large numbers and small numbers. The key is to understand what happens when you multiply by powers of 10 and when you divide by powers of 10. And large numbers are usually numbers that are more than 1.0, and small numbers are usually the numbers that are less than 1.0. But in terms of large and small, sometimes it can be a number that has many places before the decimal point, and small numbers can be a number that has many digits after the decimal point. So moving place order to the left raises 10 to the power of a positive index, and moving place order to the right raises 10 to the power of a negative index. This might sound really confusing, but it's okay. Standard form is all about practice. There's no need to know all this theory. So for example, 3.2, when you multiply it by 10 power of 1, you get 32. And here you can see that the digit 3 moved one place order to the left. And when you multiply it by 10 power of 2, it has moved 2 places to the left, and multiply it by 10 power of 3, it moved 3 places to the left, and so on. So there you see a pattern forming. Any large number can be expressed in standard form by writing it as a number between 1 and 10 multiplied by a suitable power of 10. So the step is, you count the number of places you use to move the first digit to the left, second, and the number of places tells you by what power 10 should be multiplied, or by what number 10 should be raised to. A large number, more than 1, 320,000. So 1, 2, 3, 4, 5, there's 5 number of places, so 10 should be raised to 5. And then you have a digit between 1 and 10, which is 3. So 3.2 times 10 power of 5 would be the standard form answer. So for a standard form, you can only have one digit before the decimal point, and it has to be 1 to 10, not 0. So 0.32 times 10 power of 6 is not the standard form, and 32.0 times 10 power of 4 or 320 times 10 power of 3, they are all not standard form. They have the same value, but they are not in standard form. The only standard form for 320,000 is 3.2 times 10 power of 5. So again, you can only have one digit before the decimal point, and it cannot be 0. It has to be a digit from 1 to 10. I mean from 1 to 9. Okay, so it's a same concept for small numbers compared to the large numbers. It's just that they are moving in the opposite direction. So 2,300 divided by 10, or times 10 raised to negative 1 gives you 230, and so on for 10 raised to 2 and 10 raised to 3. So the example for 0.004, first you start with a number between 1 and 9, so in this case 4. So 4 needs to move 3 place orders to the right to get from the new number 4.0 to the original number 0.004. So third, 3 places to the right is 10 power of 3. So therefore the answer would be 4 times 10 power raised to 3. Or that's an even easier way to look at it. The first non-digit in 0.004 is in the third place after the decimal point. So power of 10 is 3. So 4 times 10 power 3 is the answer. So solving the standard form numbers. 3 times 10 power of 5 multiplied by 2 times 10 power of 6. You put the like terms together, 3 times 2 times 10 power of 5 times 10 power of 6. And using the knowledge from Chapter 2, Law of Indices, link in description, 3 times 2 gives you 6 times 10 raised to 5 plus 6, and that's 6 times 10 power of 11. Or you can just convert the standard form to ordinary numbers, and then you multiply them, then you get 6 times 10 power of 11 as well. For question 2, be aware that 16 times 10 power of 10, since you get 16 because 2 times 8 gives you 16. Remember, the digit before the decimal point has to be one single digit between 1 and 9, 1 to 9. So 1.6 times 10, 16, times 10 raised to 10. Here you go, 1.6 times 10 power of 11. Question 3 uses the same concept, except for it's a division question. And for question 4, when you encounter addition or subtraction, you will write them as ordinary number. Then after you add or subtract them, you convert the answer to standard form, and that's the final answer. The last subtopic, estimation. To produce an approximate answer to a calculation, using knowledge from Chapter 1, how to round an answer to a specific number of significant figure. The step is that numbers you are using need to be rounded before you do the calculation. Although you can use any accuracy, it is usually rounded to one significant figure. So, for example, 3 times 9 times 3.9 times 2.1, approximately you round it up to one significant figure, is 4 times 2, and that gives you 8, which is the estimated value. And if you use a calculator or you do it manually, 3.9 times 2.1 is actually 8.19. So the estimated value, which is 8, is actually not far from the real value. Question 1, 4.6 plus 3.9 over square root 398. You round them up by one significant figure, so 5 plus 4 over square root 400. Then you get 9 over 20, and then 0.45. So now you check the estimated value by finding the real value of the calculation. So 4.6 plus 3.9 over square root of 398, using your calculator, you get 0.426, three significant figure, and therefore the two values are not too far. That's your estimated value, 0.45. Question 2, square root of 42.2 minus 5.1. And round to one significant figure, 40 minus 5, holding square root. So equals to square root 35. And it's worth noting that you can only easily take the square root of a square number. So round 35 up to 36 to get a square number. Square 36. And there you get 6 as the estimated value. That's the end of Chapter 5. Remember, do lots of practice with the past years and also check the learning outcome provided in the syllabus, where you can find it on Cambridge website, to make sure you are familiar with all and not miss a thing that might be asked during the exams. If there's any confusion or if you would like to have more examples and practices, comment down below and we will reply to you as soon as possible. Anyways, I believe if you practice enough, you can nail it eventually. We will be releasing videos on a regular basis. If you have any suggestion or anything to point out, such as speaking speed, details, content, do comment to let us know as well. It will be really helpful. We are looking for volunteers to answer questions asked by learners like you guys, and also producing videos like this one. If you're interested to join our team, you can either email us or DM us on Instagram. The username and email address are in the video description. So thank you guys and have a nice day.